We said capacitors store energy in the electrostatic field that's generated between the two parallel plates. Thus, we need to construct an expression to determine how much energy is stored within the capacitance based upon measurable parameters. To begin, we have to recall that power is equal to our current times our voltage. Now, work is a time integral of power, such that the work of our capacitor is equal to the integral from negative infinity to t of p of tau d tau. If we substitute IV for P within our integral, our energy stored within our capacitor is equal to the integral from negative infinity to T of V of tau I of tau d tau. Now, if we express our current in terms of our capacitance and voltage, our energy stored within our capacitor is equal to C, our capacitance, which is a constant value that does not vary with respect to time or change of voltage, times the integral of negative infinity to T of V of tau d of V tau d tau d tau. And what we see is our d taus cancel out, and we have the integral from negative infinity to t of v of tau d of v of tau, or we are integrating v with respect to dv. That means the energy stored within our capacitor is equal to our capacitance times our voltage potential squared per 2, evaluated between our bounds when tau is equal to negative infinity to t. If we let our voltage at t is equal to negative infinity equal 0, our energy stored within our capacitor is equal to our capacitance times our voltage squared per 2, and this has units of joules.